The solution for this equation is, suppose I have two derivatives, that is dy divided by dx. There is nothing but the first derivative. To find out fourth order, and if I consider first derivative x0 plus h y0 plus k3 z0 plus L3, I want to compute K1, K2, K3 as well as K4 because it is Runge-Kutta method 4 or order 4. Hello to all, a warm welcome to my new session on 4th unit, and the chapter name here is Ordinary Differential Equation. I am your Revati ma'am, faculty from the Department of Computer Science, Vidyashram First Grade College, the Temple of Excellence, Mysuru. So dear student, in my last session, I started with Runge-Kutta order 2, in the sense second derivative. Along with that, I have discussed Runge-Kutta order 2 formula as well as some of the example problems. But in my today's session, I am going to deal with Runge-Kutta fourth order. So here, if I consider Runge-Kutta second order, I want to find out K1 and K2. But if I consider Runge-Kutta order 4, I want to consider K1, K2, K3 as well as K4. In the sense, I want to calculate 4 orders, that is K1, K2, K3 and K4. Anyway, dear student, let me to start our today's session with Runge-Kutta fourth order. Now, see here, consider the initial value problem. What is the initial value problem? I am having the function of x comma y, that is represented y of x naught, that is equal to y naught. Then I need to calculate y of x naught plus h. So what is h? H is nothing but the step size or height. So we have to calculate 4 orders, that is K1, K2, K3, K4, where to find out K1, I am going to have the formula HF of x0 and y0. And if I want to find out K2, then I am going to have the formula HF of x0 plus h by 2, y0 plus k1 by 2. Now, if I want to find out K3, then the formula is height function of h0 plus h by 2, y0 plus k2 by 2. Now, K4 is nothing but hf of x0 plus h, x0 plus k3, where the required y of x0 plus h equal to y0 plus 1 by 6 k1 plus 2k2 plus 2k3 and k4. Now, the solution for this equation is, suppose I have two derivatives, that is dy divided by dx. There is nothing but the first derivative. And if I consider dz by dx, then I am going to have the second order derivative. Then it is represented as y of x0 equal to y0, then z of x0 equal to z0. Then I want to calculate K1, K2, K3 and K4. So these are nothing but the first order derivative. There is nothing but f of x, y, z. Suppose if I want to find out second order derivative, then I want to consider L1, L2, L3 and L4. There is nothing but g of x, y, z, where to find out K1. Now tell me student, where we find this kind of formula? in the second order. That's nothing but the Runge-Kutta second order. Instead of F, I am considering G. So here what I have, K1 equal to HF of X0, Y0 and Z0, L1 of HF of X0, Y0 and Z0. Now see here. X, that is K2 is nothing but HF of X0 plus H by 2, Y0 plus K1 by 2, comma Z0 plus L1 by 2. Whereas L2 is nothing but HF of X0 plus H by 2, Y0 plus K1 by 2 and Z0 plus L1 by 2. To find out K3, I have HF of X0 plus H by 2, comma Y0, K2 by 2, comma Z0 plus L by 2. Now, if I consider second derivative, then X0 plus H by 2, comma Y0 plus K2 by 2, comma Z0 plus L2 by 2. Okay, fine. Now, to find out fourth order, and if I consider first derivative x0 plus h, y0 plus k3, z0 plus l3. And to find out second order derivative, it is x0 plus h, y0 plus k3, then z0 plus l3. And when I simplify, I'm going to get y of x0 plus h, that's nothing but y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Then if I consider second order derivative z of x0 plus h, that's nothing but z0 plus 1 by 6 of L1 plus 2L2 plus 2L3 plus L4. Okay, this is the Runge-Kutta formula. So dear student, to solve the problem, you have to remember this formula. Okay, you have to remember this formula, that is K1, K2, K3 as well as K4 along with this formula, that is y of x0 plus h equal to y0 plus 1 by 6 of k1 plus 2k2 plus 2k3 plus k4. So dear student, let me to consider some example here. So here the given question is given dy divided by dx of, that is 3x plus y by 2, where y equal to 1, that is y not equal to 1, x not equal to 0, and I want to find out y of 0.2. And what is the height? It is 0.2. And I want to use Runge-Kutta fourth order. By the data, so function f of x comma y, that is, this is the given data. Okay, 3x plus 2y. Okay, and x naught is 0, y naught is 1, and h is 0.2. And I need to compute K1, K2, K3 as well as K4 because it is Runge-Kutta method order 4. So I want to find out K1, K2, K3 and K4. To find the K1, I have HF of x0 comma y0. So what is x0? It is 0 and y0 is 1. And what about h? H is nothing but 2. Okay, and when I substitute and when I simplify, I am going to get the answer 0.1. Now, if I consider K2, that is nothing but the HF of x0 is 0 and h is 0.2, y0 is 1 and K1 is 0.1 divided by 2. Okay, and when I simplify this one, I'm going to get the answer 0.165. Now, dear student, I want to find out K3. To find out K3, I have the formula hf of x naught plus h by 2, 0, 0.2, then 1 plus what is K2, that is 0.165. So 0.165. Okay. And when I simplify that one, I'm going to get the answer 0.16825. Now, I want to find out Runge-Kutta fourth order, and the formula here is h is nothing but the height and function is nothing but the first order derivative. So, here it is 0 plus 0.2, then 1 plus 0. That is 16825. So I'm getting the answer, that is 0.236825. Now I got K1, K2, K3 as well as K4. Now what I want to do, I want to find out y of x naught plus h, that is equal to y naught plus 1 by 6 K1 plus 2K2 plus 2K3 plus K4. So here y of 0.2. In the question they mentioned that I want to find out y of 0.2. And when I substitute all the values and when I simplify, I'm going to get the answer 1.1672208. That's nothing but y of 0.2, which is equal to 1.1672208. Now, dear student, I'm going to have my second question, that is, use fourth order Runge-Kutta method to solve x plus y divided by dy by dx equal to 1. And I want to find out y of 0.4 equal to 4 at x equal to 0.5, correct to 4 decimal place. So y is nothing but 1 and x naught is nothing but 0.4. And I want to find y of 0.5. Okay, fine. Now, in the question, I'm not having h value. Okay, so here x naught plus h. Okay, now I want to find out h because in the question I don't have h value. So here we have dy divided by dx, and when I simplify, I'm going to get 1 by x plus y, and y is nothing but 1 and x is nothing but 0.4. Okay, so that's nothing but the x naught is 0.4, y naught is 1, and I want to find out y of 0.5, where x naught plus h is nothing but 0.5. Over, fine. Now h is nothing but, okay, 0.5 minus x naught. So what is x naught? X naught is nothing but 0.4. So 0.5 minus 0.4, it is nothing but 0.1. Now what I want to do, I want to compute K1, K2, K3 as well as K4 because it is Runge-Kutta method 4 or order 4. So K1 is nothing but hf of x naught, y naught over x naught is nothing but 0.4 and 1. and it is 0.h is nothing but 0.1 and 1 divided by 0.4 plus 1, and when I simplify I am going to get the answer 0.0714. So dear student, now I want to find out K2. So K2 is nothing but HF x naught plus h by 2 y naught plus K1 by 2. That is nothing but 0.1. H is nothing but 0.1 and function of 0.4 plus 0.1 by 2, and here K1 is nothing but the 0.0714. Okay, divided by 2. And when I simplify this one, I'm going to get the answer 0.0673. And if I consider K3, I want to consider K2. That is x naught plus h by 2, y naught plus K2 by 2. In the sense, in each round, I'm going to use previous K value. Okay, so here I'm going to consider K2. And h is nothing but 0.1 and x naught plus h by 2 is nothing but 0.45 and y naught plus K2 by 2 is nothing but 1.003365. And here 0.1, that's nothing but the h, and 1 by, I'm going to substitute all the values in the equation, and when I simplify, I'm going to get the answer 0.0674. And dear student, if I consider K4 here, I'm going to consider the previous K value. That's nothing but K3. So here, HF of x naught plus h, y naught plus K3, then 0.1 of 0.5, 1.0674. And when I substitute these values in the equation, I'm going to get the answer 0.0638. Now, dear student, I want to find out y of 0.5. So here to find out y of 0.5, I have y of x plus h equal to y naught plus 1 by 6 of K1 plus 2K2 plus 2K3 plus K4. That is nothing but y of 0.5 equal to y naught is 1 plus 1 by 6 of, and I'm going to substitute all the K1, K2, K3 and K4 values. And when I simplify, I'm going to get the answer 1.0674. That's nothing but y of x that is 0.5 is 1.0674. So dear student, if I consider Rangekutta order 2, I want to find out only K1 and K2. Okay, fine. Then I want to calculate given y of x at, that is y naught plus K1 K2 divided by 2. But this one is Rangekutta order 4. So I want to consider y naught plus 1 by 6 of K1, 2K2, 2K3 and K4. Anyway, dear student, in my today's session, I started with Rangekutta 4th order method with formula as well as some of the example. And from the examination point of view, Rangekutta order 2 and Rangekutta order 4 both are very, very important. And you can expect one sure question under this two topic. Anyway, dear student, let's meet in the next session with the new chapter, that is numerical integration. Until that, keep watching and keep learning. Thank you.